Okay, we're going to go over how to go through your physics problems. So the first thing we want to do is make sure that you guys are always drawing a picture. It may seem like a silly little step that you could easily forget about, but with Physics 30, you need to be able to visualize exactly what's going on. You need to be able to see the situation so that you can see the forces, you can see the fields, and in this case, you can see the energies that are happening. So the first question that we're going to do is, an arrow is fired vertically from a recurved bow. The bow is drawn back 70 centimeters, and the maximum force applied is measured as 130 newtons. The 20.6 gram arrow travels directly upwards when released. Determine the elastic potential energy stored in a fully drawn bow, the maximum kinetic energy of the arrow, and the maximum height the arrow reaches. Okay, so the first thing we're going to do is we're going to draw our picture. Now, I am a terrible artist, but it doesn't matter because we just have to draw an arrow going up and down. So we have an arrow going up from a bow. See, you don't have to be able to draw. And then you're going to pull that bow back. And if you can do the conversion in your head from 70 centimeters to 70 meters, by all means, do that. I'm just going to make this prettier. However, if you need a quick reminder, you've got your distance is equal to 70.0 centimeters. You're going to take that decimal point and move it over 2 to get it to 0.700 meters. It tells you that the force is 130 newtons. That is what it's taking to pull this string back. That is going to be the initial energy that we put into the bow. Then our arrow is going to start to move. So for this section here, the arrow is going to start to move, and the only thing we know about the arrow in this case is that the mass of the arrow is 20.6 grams. Now, again, if you can do this in your head and you can do it easily, by all means. If you need a quick reminder, you're going to be moving your decimal 3 places to the left, which is 0.0206 kilograms. If you need a reminder as to why you need to do this, kilograms, meters, and seconds are your base units. All derived units come from those base units. So if you want to have newtons, joules, that's what this question specifically is asking about, coulombs, all of these other units that we use are derived units. Those come from our meters, our seconds, and our kilograms. Do that conversion first and be careful of it because it's an easy one to miss. All right. This section here is when we're going to have it moving, right? Okay, so in between here, when the arrow takes off, as soon as it leaves, it's going to have its maximum speed, and then it's going to, because of gravity, be slowing down the whole time until it reaches its maximum height. So it's going to slow down, it's going to stop, and then it's going to come back down to the ground. So when that's happening, this whole section here, you have EK decreasing and EP increasing. At the maximum height, your EK will equal 0 because your speed is going to equal 0, and your maximum height is going to be at that exact same position, and we are going to also have our maximum EP at the same place. With all of this information, we have more than enough to answer our question. So, what are we going to look at to start with? To start with, they're asking you for your EPE. So your elastic potential energy, the maximum energy that the bow is giving to the arrow. So if you look on your formula sheet, you're going to see that you get 1/2 kx squared. We don't have any of that information, but we have another way of finding it. We also know that a change in energy is equal to work, and that work is equal to force times distance. So we can find our EPE doing force times distance, which we know is 130 newtons and 0.7 meters. Now, I always try to keep all of my digits when I do my sub-in and my units. This helps prevent me from making a mistake later and make sure that I've converted the units because they should all be canceling out. You can choose whether to do this or not. It's a good habit to get into. If you do need to go faster, it's easy to stop yourself from doing it, but it's harder to add it in if you don't ever get into the habit. This is going to give you 91.0 joules worth of energy for our EPE. That's going to be the maximum amount of energy that this bow puts into the arrow. Now, because of the magic of the conservation laws and conservation of energy in particular, this also is the EK max that we have for our arrow when it leaves the bow, 91.0 joules. It's going to be exactly the same. Now, once you have that, you can then say, I know that my EK max is going to equal to my EP max, which is equal to mgh, which is the maximum height, which is what I'm looking for next. So therefore, we can find our height is equal to EP over mg, which is our 91.0 joules over our 0.206 kilograms, I missed a 0, kilograms times 9.81 meters per second squared. When you are calculating this in your calculator, make sure you put this into brackets. If you don't put it into brackets, you will not get the right answer because you'll be dividing by one and multiplying by the other. Once you do that into your calculator, you should get 450 meters, which is the maximum height that you're looking